Okay. Looks like we are live. Hi, everyone. Is the sound okay?
Yeah, I hear you well.
And I hope other people also hear as well. Yeah, it seems like it. Okay, then let's get started. Um, yeah, the stream is doing well too. So, all right, excellent quality. All right, that's probably because you're on campus, have extremely good connection.
Yeah, as I hear
Okay,
you well.
yeah. Okay, so thank you all for joining us again. Like every month, and for the last month of the year, this is our, I guess, winter holiday session. Um, and we are thinking, as usual, about the nature of intelligence and what parts of sciences can help us answer questions about the mechanisms of intelligence in natural systems as well as artificial systems. And this is organized as usual by our institute. It's called Cross Labs, so you can check it out on crosslabs.org. I just posted a link. And our research institute is a sort of nice new kind of university, and we are trying to distill knowledge from disciplines of mind, brain science, mathematics, AI, neural nets, and artificial life, and much more. And we are also trying to bring new technologies from the industry together with well, changes in society too, together with academic research endeavors. So the cross from Cross Roads, the name of this event is also the name of Cross Labs, our lab, and the name of the company that founded us. Co-founded by um, uh, Antoine Pasquali, Katsunobu Suzuki, so our CEO at Cross Compass also. So that's a AI tech company called Cross Compass. You can also Google that. I post a link. And I want to thank everyone who is helping to prepare this behind the scenes. All right, so today I have the pleasure of introducing Mahdi Khosravy. He's a scientist in widely interdisciplinary intelligent systems, has done work in machine learning, deep learning, deep model inversion, cybersecurity also, different types of recognizers. Also, he worked recently on evolutionary optimization, different types of optimizers, also a new Mendelian evolutionary algorithm, and also a lot of experience in signal processing, image processing, telecom, really a lot of very cool stuff, and he'll mention some of that today. His background, well, is in electrical engineering, I think, in machine learning. And I think Mahdi graduated from the University of the Ryukyus in Okinawa. He got his PhD in intelligent systems. He got even an award for excellence by the university. He got a lot of awards. Maybe I shouldn't go over over all of those. He also authored a few books. I think four. Was that four,
Oh, good.
Mahdi?
Yeah, before.
Pretty nice, and a lot of articles. He also has some experience as a visiting professor in Brazil. Also, he was an associate professor in Macedonia at the University for Information Science and Technology. And right now, he's a specially appointed researcher at Osaka University in the Media Integrated Communication Lab. And yeah, today he's going to talk about something very special, uh, about signal image processing and where illusions can assist. So Mahdi, yeah, feel free to start
Thank
presenting
you
whenever you're ready.
Ola for very good introduction. Yeah, where illusions come to assist. Let me share my slide. Okay. So, perceptual signal and image processing where illusions come to assist. So, first I have a introduction about illusions, especially visual illusions. Normally we know illusions, we hear about illusions, and for a long time as illusions were considered as visual mistakes. So I will go through some illusions to have a quick review to some famous illusions, and then we will go through the illusions. Are illusions mistakes, or we can see them in other ways? Yeah, here the colors are fixed. You see some illusions, yeah? Already in this slide, the colors are fixed, but you can see some movement that the colors are invading each other. So illusion is coming from our mind. Illusion something is in our visual system, is in our perception. It doesn't exist outside, but it comes to us that we see in that illusory way. This is just an example that you can see the colors are moving toward each other, but indeed there is not any movement. The colors are rigid fixed. So this is not a GIF, this is a fixed image.
Mahdi, I'll interrupt you just for a quick second because the sound seems to be a bit low or slightly unclear. So maybe we can,
Yeah,
we
I
can
keep
try
my
to
microphone close. Yeah,
maybe it's better. Thank you.
I think this is the best. Yeah. So
Find a better.
as you see, the
Thank you.
colors are moving toward each other. There is some invasion of the colors to other colors. And this is the illusion in our system because in the visual system that when some color is beside the other color, they the perception of visual system see it like that one color is going over the other one. Or the famous illusion of Muller-Lyers lines. Muller-Lyers lines, this is a very famous illusion that these lines are exactly the same lengths, but we can see one of them, some of them longer and some of them shorter. If we ask somebody which line is shorter, the person will answer, okay, the upper one is shorter. And which one is longer? The person will answer, yeah, the middle one is longer. But indeed, they are exactly the same line. And this is the illusion coming from the movement of eyes. As the eyes are moving more due to that arrow tails or head, the person thinks that that line is longer or shorter. Same illusion makes this effect. For example, here you can see same room from outside view and from inside view. From the outside view, the room look like smaller, while from the inside view, the room look like bigger. And this is exactly because of that illusion. You see the corner effect that is like arrow-like, it make it look bigger, while it's the same room and the same foundation. You see, I will put a line, the same foundation size, but it can be seen in different sizes. Or the illusion of the giants or dwarfs, that both of them are exactly same size in this painting, but because of that illusion set in our brain that something that is on the horizon, perspective horizon, look bigger, and the one that is close in perspective view sounds smaller. Or here, for example, we have two rectangles. They are exactly same size, but one of them is in far perspective and the other is close perspective. So brain make that perception for us, that illusory perception, that the closer one is smaller and the farther one is bigger. Or the moon illusion. We can see here in this image two moons. They are exactly same size because the moon distance from the Earth is same. But sometimes we see the moon much bigger and sometimes we see it smaller. And that is the perception of the brain. When it goes close to our horizon landscape, it sees it big because the brain has that perception that something with that size, when located on the horizon, line, brain take it bigger because by the logic of the brain is in 4 points, so we should perceive the bigger size. But they are exactly the same size. Now, if you zoom on that cross at the middle of the page, just zoom on the cross. Do not watch the face of the actors and actresses. If your eye zoom on that point, and in directive you watch the faces of the indirective by the corner eye, okay? The faces of the actors and actresses, then you will see their faces very different, not the real faces. They look a bit strange, freak, but as you watch them directly, you see the real faces. Again, when you zoom on that cross, you see different. That is illusory effect on the brain, that the brain is mixing two faces together. So your indirect view show you a different thing. This is another illusion. Another illusion here, you can see the face of two faces here. And which one is the face of male and which one is the face of female? What do you think? So quickly you say, yeah, it's clear. The left one is the face of female and the right one is the face of male. But indeed, they're exactly the same face of the same person. And this is exactly the same shot. They just a little change the light intensity. So by that perception that in the brain perception that a female face is brighter, you see one of them female and the other one you see as a male. Look, we have two images of Pisa Tower. So which one, are they the same image? Are they the same image? Or they are different? Maybe one of them is more tilted. No, they're exactly the same images. But that is due to the angles, we see one of them more tilted than the other one. Or this very famous illusion of the dancing girl. Depends in what way you watch the photo. Then you can see it, in different direction of dancing. Some people, they see it dancing, clockwise, and some people, they see it dancing, anti-clockwise. Or this ground. This ground is flat. Just by putting that lines on the ground, they made that very strong illusion that there are some gravity wells on this surface that the person is worried, trapped in some of them. This is another interesting one. Look at the dot at the center of the image for a while without moving your eyes. And do not move your eyes and keep it fixed on that black dot at the center of the image. Keep your eyes fixed on that black dot. Do not move it. Do not move it. And right now you see a colorful image until you didn't move your eyes. As you move your eyes, suddenly you see, oh, the image is black and white. Absolutely black and white. So the perception, the background that it was in your brain from before, because visual system is inside the brain, not only eyes, it made that effect. Or this illusion of the blue and green spirals. They are blue or green. You see, we have, okay, the pink one, the pink spiral, take it away. So you can see a blue spiral and a green spiral. So the green spiral and the blue spiral, they are green or blue? No, they're exactly the same color. This is also an illusion of the effect of the background color. Or this famous illusion of the black dots. You can see some black dots are appearing, but as you come to follow it on the intersection, on the crosses, as you come to follow and catch it by your eye, they disappear. So where they go? Nowhere, they don't exist. Or this spiral illusion, Fraser spiral illusion. Indeed, there is not any spiral here. They are concentric circles. But because of that design and effect of background and foreground, draw on that circles, we see them as spirals. No, they are not spirals. Or Zollner illusion, or coffee wall illusion. There are other famous illusions. In the upper case and in the lower image, in both images, the parallel lines are exactly a straight parallel line with the exact, completely parallel. But you can see their distance are changing. They're getting closer or farther from each other. So that's not true. They are exactly straight because of the set of background. We see them like that. Another illusion. All pinna illusion. If you look on the point at the center of the image and you bring your face close or take it far, then you see the circle is rotating. Yeah. Or if you rotate this, we think it's uh, expanding or contracting. They're getting close or expanding. While there is not such thing, it's just an illusion. So that movement of moving the circle or expanding or contracting is happening in our brain. And so on. We have other illusions like these. For example, these two orange circles are exactly same size, but because of the surrounded circles of different sizes, we see them in different sizes. We have a lot of visual illusion. So the question arises, we should avoid illusions, we should fix illusions, or we can take help from illusions. Already there are, a lot of research work is carried out, in psychology, in vision, visual system, that they are using illusions for understanding human perception. My point today in this presentation is we can use illusions to help signal image processing. In what way? We can see illusions as assistants, brain assistants to to perceptual system. So human body perceptual system assistant for having a better perception. If we see illusion in this way, we can take help from illusion by boosting the illusory effects. Because according to the age, according to the mood of the person, that illusion effect is different. Because same illusion, different people, they can see it with different effect and power. So using the same idea, one of the very famous illusions, that is the match bands illusion, we use it for image adaptation. It's a kind of image enhancement. We perceptually adapt the image to human visual system. Here you can see the match bands, the gray bands colors on the top. So there are the gray band colors on the top. Every strip of the color is exactly the same tone without any change. As you can see here at the middle, the actual intensity. But what the visual system of the person perceive is this, the one on the bottom. By coming to the edge, you see the edges are highlighted. The brain highlights the edges. So a kind of sharpening happening by human perception. Here, so we use the same effects. We said, okay, the human perceptual system, human visual system, highlight the edges in that illusory way and help to see better the edges. Why not? We can apply the same effect on an image and adapt to it, and perceptually adapt the image to a human visual system and to have a kind of image enhancement that we call it perceptual adaptation of the image. For example, here you can see one image on the left that we use the morphological operators and we apply these effects on the edge and we made it like this. And from this, it changed to this one. Yeah, you can see much better the edges by this effect. So to do this, we use morphological operators and we made a mask. First, we define an overshoot. When an edge is going up, we make it having not only having an going off edge, also having one overshoot, and one with it goes down, we make an undershoot, and this mask of overshoot and undershoot we add it to the image, and then from this one we come to this one. We define, we applied morphological operators when we are using opening operator and closing operator to make that mask. Morphological opening, morphological closing, these famous morphological operators. We put them in one algorithm, as you can see, a very simple algorithm. We apply and we observe. Here, for example, in this vector of the rose flower, on the left, we boosted that illusory effect of match bands by applying morphological filters, and we have the one on the right. You can visually see the difference without using any numerical method of visual image quality. Also, we applied image quality metrics, and we saw the enhancement. In article that we publish, we use 6 or 7 different metrics, numerical metrics for visual, for the image quality. For Barbara photo, we applied a structuring element of the size of 7 by 7. And you can see the light intensity, everything is the same. Just the image on the right is perceptually adapted to the human vision according to that illusion. So the illusion inspired us to do this. And we applied the same on a lot of images, as you can see. Let me conclude this talk. For a long time, illusions were considered as a visual mistakes, but indeed they are not visual mistakes. They are assistants to have a better perception of environment. So we can artificially introduce the same illusion and add it to the media that we want to highlight it for the brain. Okay, we can say multimedia highlighting by inspiring from illusion. Also, there is a great potential for possible applications. For example, you saw that illusion that the colors were moving where there was not any real movement, because that brain had that perception when this color and this color, some special type of color tones are adjacent to each other. The brain had that perception that one of them is moving toward the other one. So using that one, we can make moving lines. It can be used, for example, for a lot of applications, like, for example, in traffic system, or, for example, in barber shop, that's rotating stuff. They put a mechanical rotating to make the color moves. While no need to do such thing, we have the colors when they are adjacent to each other, the human perception see them automatically moving. So a low consumption LED light and the color tones with a low consumption of energy without any mechanical waste, we can simulate the same thing. We can build it and make it usable.
Thank you, Mahdi.
Welcome. So let's go to the question, yeah?
Yeah. So from now, yeah, if anyone wants to ask questions, I'll post the link. There we go. Here we go. All right. And, yeah, I guess, yeah. And if anyone from the Zoom wants to ask a question directly, that's fine too. So you can just speak up or post something in the chat. Yeah.
Okay.
So yeah, shall we start with this one? So do you see any applications of this work to generating adversarial examples for computer vision systems?
Generative adversarial examples. So it can be taught to us. We can think about it. How generative adversarial examples. Maybe for discovering illusions, we can use, you know, generative adversarial, models to discover more illusions. Or to apply illusions, maybe we can use generative models. But these are different topics. These are different topics.
Yeah, I
At the
guess
moment, I don't see any link.
Right. Yeah. Yeah. I'm not sure how. Yeah. In which direction this question is pointing. So yeah, if whoever asked it wants to give a compliment of of direction,
I don't know.
otherwise. Otherwise, the I guess the adversarial examples could help computer so computer vision to classify or perform different tasks, I guess, in computer vision by generating those and maybe the question would be does your method here could that be used in a very simple way to enrich or
Maybe the
a
question
data
can
set.
be like this, for example, generative adversarial examples, like again, they were used to discover the human perception, human view, they have used some research to see what an eye see, what brain perception is. It was used in some other research, and also illusions were used to have some, approach to the perception of the person or any other. Maybe they have same direction, but I don't see the overlap of these two methodologies.
Right. Yeah. Yeah, that's interesting. I guess there is a lot of things to be said in that area. So we can continue on that later. Kevin, I see you have a question. Do you want to ask it directly?
Yeah, sure. Is my mic working?
Yes,
yes, it is.
we hear
Cool.
you.
Yeah. This is just kind of something that I was interested in. Was that like early in the slides you said that these aren't like these illusions are kind of a byproduct of like in real life these are helpful things to recognize, like the boundaries between two colors. So I was wondering, like, do you think like if a computer vision system was trained on some general task, would they also kind of exhibit these illusions? Like, would they see something as being smaller or bigger if they were surrounded by like the context?
Yeah, like that one, for example, to look bigger, to look smaller. Yeah, macro, that has a term also in psychology, microsepia, like that. So to make it look bigger or look smaller, that is a very simple application. But for example, movements to draw attention. For example, the borderline of the road when you're driving. Yeah, right there they put, like for example, sound when the car is going on that, then making sound, and you are going out of the road. But also they can make visual attention. Visual attention to some entrance, to even for some advertisement, you want to draw attention. So when you move forward, the lines start to move. These are all depends on the creation, creativity of the people. Also, a lot of illusions are created by the people. There is a competition every year, the illusion of the year. So
interesting.
they make a big computation work, worldwide, and people they try to make illusion. So very good illusions were made by Japanese professors. Number of illusions that I showed here originally they were by Japanese professors that are working on the vision and psychology, because the illusion can mainly belong to the vision and psychology. Maybe this article that we had was one of the very few ones that used illusion for signal and image processing.
Cool. Yeah, thank you.
Yeah, I guess it's interesting to have them feed back into each other. That's really in the spirit of cross labs. Have the natural help the artificial systems and vice versa. Yeah. I like the point about detail. I think that was mentioned in I think Feynman mentioned it in surely you joking, Mr. Feynman, right? When he talks about dreams, there was something about him being able to see as much detail as he wanted in everything in the perception. And I guess it is something that might be generated by just the power of generalization of your cognitive system.
One thing is, for example, illusions are making us more alert to something more than other. Yeah, like when we see the image, edges are really important. You know, edges of an image are really important. So the edges are highlighted naturally. That we notice that the edge here, there is an edge here. The regions of view is changing. Also, there are a lot of other issues. When we perceive it, we must be more alert to it because of danger, because of whatever in the nature. So that system is inside us. So something can be applied.
Right. Thank you. Let's. There are a few other questions. Let's see. Someone here asking, an image classifier trained into overlaying in AR a fix, quote unquote, of these illusions to filter the looks bigger or looks smaller. We would have objective perception, question mark.
To my very much knowledge, to my knowledge, there is not such thing. You know, they didn't go to work on this. Illusions are studied a lot with the psychologists, with the scientists in the field of vision, but not from the engineering side and from the artificial intelligence, machine learning, this other side. It was not studied by this side that how they can use it. And whatever we have from this side, they came by the logic, mathematics, and engineering. Yeah, we can sharpen an image like this. But we see, wow, illusory system, matchband effect, the brain is doing the same. How is the pattern of brain? Let's do the same that the brain is doing. We can boost it on the image. What we did in that paper. A lot of people, they said, no, this is not something new. It's something that's already done, but not by that inspiration. I received a lot of comments later on the published paper. I was lucky that reviewers didn't have that view.
By the way, we'll ask you for the link to that paper. Maybe some would like to have a look. So I'll share it on the YouTube channel later.
Share it.
And I guess this kind of this kind of concept has to be. We could put it in there in the form of some kind of function or some kind of emerging goals, even given the
chapter on the presentation, and also there is a IEEE signal processing letter on the same presentation. So it's really good if the link of both of them be provided there.
Good. All right. So Lisa, I see you have a question. Do you want to ask it directly?
Sure. Yep. Just had to get my mic going. My question was mostly about whether this phenomenon of illusions is mostly only something we experience visually, or if there would be something like illusions that happen in other senses, whether it's like hearing or smell or touch or something like that.
That is a very good question, because when I was, working on that vision adaptation, perceptual adaptation of image, all the view was vision, but it can be all type of perceptions, like touching, like even voice, and the research can be extended to all type of, all senses that we have, and even can go further the senses. It can be, about everything that the brain, because some of the illusions that we have is according to the logic in the brain. Like, for example, there is an illusion, if we put some points, like constellation of the stars, then the eyes make line and connection between them, when there is not any line connection between them, but the eye make that. So this is coming from the brain logical structure that want to make a shape. Yeah. So we can see that it's coming from the way of thinking. It's even more than perception.
Yeah, it's quite interesting though. maybe some of those are translatable into different senses and some of them aren't. And yeah, I don't know exactly what is the limit in translation between different senses. I guess there are people that around us that study synesthesia. It would be quite interesting to see what is possible or not. Maybe someone in the room knows about it.
Yeah, cool. Thank you.
You're welcome.
Okay, so let's maybe take Antoine's question. Don't see him here, so let's see. Right, so do you know of other practical application? So such as the habituation process, inverting colors appearing in image after fixation dot, may help with night vision. Ah, I see. Mm-hmm.
Yeah, that's a very ideas are coming. Ideas are coming because I just went to this topic from the view of signal processing. Yeah. Then I started to read psychology papers and to make inspiration. But when from the other views come, other fields of other views, applications will come. And I think the main effect will be improvement or some application from scratch. Who knows?
I see.
Process, yeah.
Mm-hmm. Yeah, it's tricky, but yeah, it's possible that we find something. Yeah, this is not a normal path of thinking about illusions, I guess. We usually try to understand illusions, understand how there are errors or not. Like you say, yeah, that they're not really errors as much as certain useful biases.
Yeah.
Maybe there are also useless biases. I'd be curious. I see Lana is not here, but she also so she presented a few months back, and she also made an artificial machine about illusions. So yeah, it would be interesting to discuss that further later on. I see that Acer, you have a question. You're in the room, right?
Yes.
You want to ask it?
Oh, okay. Thanks. Yeah, so thank you for your talk. I'm always very interested in the illusion of neuroscience. So I also connect to our study. So I think a general theoretical question is, does your work or other work about illusion in recognition system kind of imply that there is a upper bound of average performance across all data set for the recognition system? So, and then we kind of introduce some inductive bias to make the recognition system can be better for some more frequently same data set. And then we sacrifice recognize some less frequently same data set. Is I kind of optimize the trade-off. Is it true?
I think so. It makes sense what you said.
Okay. I think my following question is so how do we know like the kind of this outbound theoretically, and is there any systematical way to know like how kind of inductive bias and we can get better in some data set and we lost something in other data sets?
Your question is exactly how we can make it systematic to see about the loss of data, you said?
You mean like for so for example, if like a human, we already adapt to this these words, so we try to make correct inference. for the current environment. But of course, this is only a small set of all possible image, and we may make wrong inference about those less frequently seen data. Yeah.
You pointed to the environment.
Yes.
And
exactly.
yeah, one work of the illusions is highlighting the environment, details. Okay, so
Yes.
we can see which detail of environment is more important for us. Yeah, for example, in some robotic
Yes.
research or artificial intelligence research. So we want to see we have an environment and we have a, let's say, agent or the person, because when we are talking about illusions, we are talking about also the person. So we want to
Yes.
see what in the environment, what details is more important for us, and we want to highlight that one. And also we can, remove the other one that they have less importance. So
Yes.
this research that I was talking about was mainly talking about boosting the illusory effects to perceptually adapt the image. It can be done also reversely, to make
Okay.
that image, less perceptive. Like image blurring has the same effect when they blur the. It can
Yes.
be same to be done about the environment. Yeah. So some environmental effect can be boosted. Our brain also is doing such thing, by time. You see, for example, we are more sensitive to some voices rather than the others, especially the voices that we know. Yeah. So in a
Yes.
party, a lot of people are talking. We exactly hearing very well the voice of one person, that our brain is trained for that voice a lot.
Yes. Thanks. I think a little bit following question is, so like in your work, you use famous like visual illusion in from human to extract a potential underlying mechanism and build that in the artificial system. And so I think uh, this is uh, this is some given information we we have known. So we have some illusion from psychology, and we also have some natural image data sets, so we can link them together. And I think I want to ask a more general question. Is like, okay, if I have a system and I want to train it for some specific data sets, and can I some kind of theoretically to know if I train for this set data set, then I may sacrifice something else. That can we know that?
Is there any perception on your data? First question. Because for example, in the case of image, it was perceived by vision. Yeah.
Yes, yes.
So is there any perception applied to your data? Because
Of course. There must be a recognition system, and yeah, and it could be trained by any other things like maybe not vision or something. Uh, can we kind of predict what kind of illusion you will get? For example, like auditory illusion.
yeah, with for example, in the face recognition system,
Yes,
we can see what illusions can make us confuse the faces. Yeah.
yes,
Then after discovering the illusion, because they are discovering illusions right now, they are making illusions. So I told there is a competition every year to introduce new illusions. So
yeah,
after discovering new illusion related to the face detection or confusing the faces of different people, then we can make some, maybe we can define that illusion systematically, So
yes.
then after having a systemic definition of that illusion, we can apply it by algorithm and say, yeah, we make a more efficient recognition system. Yeah.
I see. Yeah, that's quite interesting. Yes.
Or it can be used for attacking a recognition system, to not well recognizing.
I see. Okay. Yeah, that's cool. Thank you. Yeah, thank you for your answer.
For your very good question.
Thanks for the question, Acer. And we have a question from Antoine, I think, about deep learning models. So could deep learning being data-driven used to for stereoscopic vision, already being made susceptible to some illusions, for example, related to perspectives? Yeah, I guess that's related to some projects we're working on also.
Yes, we should see what illusions exactly there. I think the deep learning, has a very strong power to see. We have, for example, input, and then we will have an output, and then we can see the illusory effects, tracing the illusory effect by using deep learning. Yeah, it's a very good idea, but the details is a matter of the how to apply it, how to make it work, how to go through it is a matter of details.
Yeah,
I see that potential.
Yeah, I guess there are many things that they could be used for. Maybe optimizing some specific, maybe interconvolutions even. Yeah, I don't know exactly. Maybe maybe Antoine will speak later when he joins us here. But yeah, I'm thinking maybe more in general. What do you think about what would you do to further this research? What would be a nice next step that would be exciting to you? It doesn't have to be deep learning; it can be anything. But in the same kind of trend of using illusions for an application.
Well, first there should be a good knowledge of the illusion of their work. Which illusion? That illusion is in connection with which perceptual system. Okay. Then, for example, in the case of the image enhancement that we use for the visual adaptation of the image, there was open, and it was open, this part of the problem, how to optimize that adaptation, because we just applied some morphological filter masks without any optimization, and it was working. And we followed some general formulations from the psychology papers of the same effects. So we inspired the same effects formulations from those psychology papers, and we apply on the image. But it was open to optimize it. So optimization of the effect, it was one way. But thinking bigger, having a big view, going for another illusion. So I think first we should see what illusions there is. Finding the illusions. Finding the illusions, then working on the illusions.
Yeah, I guess it's presupposing that we understand any of those illusions. Well, maybe some, but would be to say a lot. But yeah, I see the idea. And probably understanding a bit more. I probably can do a bit of both and make both advanced.
3D view is illusion. Yeah.
Yeah. Yeah. All right. Yeah. Is there any other urgent question that we'd like to talk about here from anyone in the audience? I see we might. Let me look at the list. All right, one last one. Okay, how could seeing ugly faces in our peripheral vision in the famous people illusion not be a mistake?
Be a mistake. Not to be a mistake, yeah.
Yeah.
Well, you see the images that we had, the actors and actresses, okay, they are celebrities, they are good faces. And when we were zooming on that point, the things what happening, I think, I'm not sure about the reason behind that illusion, but I think the face parts were mixed together in the perception of the brain. So the symmetry was gone. and those strange faces were coming, or ugly faces.
Yeah.
Yeah, I guess. Well, yeah, it depends what we mean by mistake. But I guess if you don't use the system just exactly for its purpose, and it hasn't been trained to be more robust, then yeah, you're doing something very close to a mistake. Maybe there are different categories of mistakes also, but it's definitely an interesting one. All right, I think we'll go offline in a moment, and we'll keep chatting informally as we usually do. So Mahdi, thank you again for joining us today.
Thank you for all arrangement, your time.
Yeah, thank you so much, and yeah, we'll have this video uploaded on YouTube. It will stay there. So and we'll also add the links to relevant articles as usual. Okay, thank you so much, everyone, and
Thank you.
we'll go as soon as I find the button. So for whoever wants to join us on Zoom, it's still possible.